All right, let's dive right in. Today we're talking about something we all think we know, something we live by every single second, but something that's way, way weirder than you can imagine. We're talking about time. And believe me, its true nature is a real mind-bender.
So let's just start with the biggest question there is. What is time? I mean, really. We see it as this river, right? Constantly flowing, carrying us from the past through this moment and off into the future. But what if that's all wrong? What if that whole idea of a one-way flow is just an illusion our brains create?
It definitely feels like a one-way street. You can't unspill your coffee. You can't unbreak an egg. Physicists have a name for this. They call it the arrow of time. But here's the crazy part. That arrow, that direction, it's not actually a property of time itself. Nope, it's a property of the universe. And we just happen to be along for the ride.
Okay, to really get this, we need to look at two big ideas. First, there's energy conservation. This basically tells us what's possible. You drop something, its energy changes form. Simple enough. But that doesn't explain why you can't just gather up all the heat and sound from the impact and watch it jump back into your hand. That's where entropy comes in. Entropy is the secret sauce. It's the measure of disorder, and it explains the direction of everything.
Think about it like this. The universe is always moving from a state of order to a state of disorder. Always. A clean room doesn't just spontaneously get cleaner, right? It gets messy. That's entropy. An intact, ordered system releases energy and becomes a chaotic, irreversible mess. And here's the kicker. This relentless march from order to chaos, that is what we perceive as time moving forward.
And this isn't some far-off cosmic thing. It's happening inside you right now. Why do we get older? It's entropy. It's our own bodies following that same universal rule. Over our lives, our cells, our DNA, all of it just becomes more and more disordered. Eventually, the body hits its maximum state of disorder, a point where it just can't function anymore. And that final point, well, that's death.
So just as our bodies decay, the whole universe is on the same path. But what does that mean for the end of, well, everything? Is it some great big cycle of death and rebirth? Some theories say yes. But there's a fascinating and very final twist. Okay, so let's check out this big bounce theory. The idea is that when our universe ends, it could spark a brand new one. Like a cosmic reset button. An endless cycle of creation and destruction. It's a really cool idea, but it kind of forgets about the one crucial thing we just learned. Entropy.
See, it's not a perfect cycle. It's not a clean slate every time. Each new universe would actually start out a little bit more chaotic than the one before it. It's kind of like making a photocopy of a photocopy of a photocopy. Each one gets a little fuzzier, a little more degraded. And that means the cycle can't go on forever. Eventually, you get a final universe that just hits maximum chaos.
And this leads to the ultimate fate of time itself. Think about it. If the arrow of time is just the universe's journey toward total disorder, what happens when it gets there? When it can't possibly get any more disordered? Well, the journey is over. The universe would have no forward direction. And if the universe has no direction, time just stops.
Okay, so we've established that time's direction is basically tied to the universe falling apart. But what about the speed of time? That steady tick-tock we all feel. Well, get ready, because one man came along and just completely shattered that idea. His name was Albert Einstein.
Einstein gave us two incredible theories that changed everything. Special relativity showed us this wild link between how fast you're going and how you experience time. And then general relativity came along and revealed an even stranger connection between gravity and time. The bottom line for both? Time is not some fixed, absolute thing. It's flexible. It's stretchy. Let's start with special relativity. The main idea here is an absolute trip. The faster you move through space, the slower you move through time, at least compared to someone standing still. It's wild. If you hopped in a spaceship and traveled close to the speed of light, decades could fly by back on Earth, while for you, it might only feel like a few hours. Time is literally relative.
But if you thought that was strange, it gets even weirder. If speed can warp time, what do you think something as powerful as gravity can do? This is where general relativity comes in, and it tells us that gravity doesn't just pull on stuff, it literally bends and warps the fabric of space and time itself.
So get this, the more massive something is, the more gravity it has, and the slower time literally ticks in its vicinity. For example, because the Earth is way more massive than the Moon, time actually runs a tiny bit faster on the Moon than it does for us down here. But then you get to a supermassive object, like a black hole, the gravity is so crushing that time grinds to a complete and total stop. So let's put all these pieces together. Time doesn't really have its own forward direction. That's just us watching the universe get messier. And time doesn't have a constant speed. It gets stretched and squeezed by motion and gravity. So, if it has no direction and no steady flow, what on earth is it?
This, right here, is probably the most important thing to wrap your head around. We always think of the universe as existing inside of time, right? Like a movie playing out on a long film strip. But the reality is the complete opposite. Time exists inside the universe. It's woven into the fabric of reality itself. It's not the box that reality comes in.
And all of this brought Einstein to this really stunning conclusion, a quote that just perfectly sums up this bizarre new reality. He said, "The past, the present, and the future are but a stubborn illusion. That feeling we have, that the past is gone, the future isn't here yet, that's not real, not fundamentally. It's a product of how we humans perceive the world."
And that leaves us with one last kind of haunting question to chew on. If our most basic, fundamental experience of reality, this forward flow of time, is just a stubborn illusion created by the laws of physics, then what does that make us? What does that mean for our lives, our memories, our hopes for the future? I'll let you think about that one.